Hi, everyone. My name is Nour, and I am a GenAI tech lead at Twig, my Modus Create. Some of you might recognize us from last year, where we presented on evaluating the evaluators. It was an empirical analysis of RAG eval libraries and the Python ecosystems. And this year, we're presenting on the same theme, but with a more practical aspect. So hopefully, you'll get out of this talk with some practical tips and tricks that you can apply to your LLM projects. I'd like to say just a word about Twig before we start. So Twig is an international remote-first consultancy. We do a lot of open source contributions to various domains, including to the Python ecosystem. Equally last year, there's some echo I find, no? Okay, let me get back a bit. So last year, we also presented one of our open source packages, Faulty Debs. It's a Python package linter. This was with my colleague Maria and Jihan. And we do that for, so these contributions also to GenAI evaluation. So I'd like to start with some questions first. I don't see you very well, so let's see how we're going to do that. Has anyone built an LLM application before? Okay, not bad. Who was disenchanted when they realized how much work it was to get it to production? Thank you. Okay. Who's sick of LLM and AI news in their feeds? Okay. Okay, good. So yeah, we'll try to make this a no-nonsense talk, really. No hype, just practical tips. And with that said, I leave the stage to Miklos.
Thank you, Nour. Hey, everyone. I'm Miklos. I'm an AI ML engineer at Modus Create. So today, I'm gonna walk you through a few steps how you also can think about processing documents. So obviously, it all starts with like what documents you have. So in this example that we're gonna do today, we're gonna focus on marketing materials because marketing is all around, right? So all around us. This is something that's has been taken from, like, in terms of inspiration from one of our previous client projects. So the task that we are going to do is simply looking at marketing materials and trying to understand them and extracting the claims from them so that we can later on verify if any of these claims are, up for scratch. Are they do they make any sense or not? The way we are going to do this is basically, first we're going to look at what do we do with the normal text-based document, so which is on the left, and later on we're going to take a quick look at what we can do with the more visually appealing and visually rich documents, which is on the right. I have no affiliation with VitalBoost, actually. I don't know what this is. This is a completely synthetic brand, so just for the record. Obviously, when we work with text-based documents, what we need is we need to be able to extract the text from these documents. So you would immediately say well, we have PDFs, we have the text embedded in these PDFs. Well, you would think that's the case always, but it's not quite the case. So if you have a broad, diverse set of documents, you may run into issues where you actually don't have any embedded text in the PDF. So you have to kind of resort to tools that can actually OCR the document and actually can extract the text so that you can pass it on to the LLM. So there are just a few examples of services that you can use. So Amazon Textract or Azure AI Document Intelligence. So there are some open source ones too that you could use. They are actually less kind of reliable, but we have just added one example here, which is Markdown. So once we have taken these documents, running through this service that extracts the text from them, we can go to the next place. We have the Markdown, so it's all great. It has sections, so we can partition the document based on these sections or based on the pages. And then we can actually get down to running, running some logic on it and actually doing the claims extraction. So in order to do that, I'm gonna find a tab that has the right thing, which is, okay, let's see. What we'll try to do here is basically just use, the tools available. So one really powerful tool that we have found is basically the cloud platform. So if you have this task, like we want to extract marketing claims from a document, so we just go and we just use the prompt generator to bootstrap all of these things, and I'm just gonna just enter some details for this task. So let's focus on extracting the, let's do marketing claims analysis on the brochure contents. We're gonna ask the LLM to actually review the document first, because you always have to kind of, you should actually trigger the chain of thought and chain of thought prompting, and then also we will do we will add some details on like what do we want for each claim. So for each claim we want actually the claim text verbatim, because that's what usually you can use in a downstream in the other step in the pipeline. We want a category for it, like a marketing category, and then an assessment of its verifiability, because this was our main task. So I'm just gonna say like it's low, medium, high, plus any red flags or concerns about the claim's accuracy. So I know that this is something you would probably drool on and just do it in over a longer period of time and come back to this prompt, etc. So this is not, we don't really have the time for it. So let's just go with this one. So now what will happen is that basically this feature in the cloud platform is going to generate a prompt for us that follows all the best practices. So we actually don't have to be kind of explicitly be aware of all of them, but it's a great thing if you understand that we should be really clear and direct with our prompting. So don't say like vague things, but say like explicitly what you want as a result, and use also examples. So we can also see like there is well, let me just continue and then we can take a quick look at this prompt actually. So now we have our prompt, and it's let's see. So it has we have the kind of we tell the model what is the role that is being played here by the model itself, or what is the goal. We have the categories defined. We have the verifiability defined. We have we also tell the model like what is the process they should be going through. So this helps with the more like grounding the results better. And then we also have the output format in terms of like what are the different pieces of information we want to extract, and we also have some examples. So this looks like actually a pretty good prompt. So let's try to run it. I already have this brochure content here, hopefully. Yeah, I do. So we can just run it. This actually uses the latest Cloud Sonnet 4.5, which just came out this week. So it's a pretty new model and it's pretty good. So till this runs, so a few other things that we should be actually aware of is one is that without having structured output, the main problem is going to be that the model generates just some text. So if we were to read it as humans, it's okay with us, but we can't really use this in a production-like environment. So the next thing that we should really do, and this is actually a pretty important step, is convert the output to be actually structured. So I think I'm going to just improve the prompt right away with this. I'm not going to even look at the results. As you can see, it's just a long wall of text. So here we have the improve prompt feature. So this is actually we can use this to actually change the original prompt with saying like, let's say a structured output and return all the claims under a marketing claims tag with the following fields. Even if we didn't say any fields, I think it would be fine. So I'm just gonna make up some quick categories here and verify ability. And then you can tell me like how bad I type. I know that's it doesn't work great. So this actually takes its use is more like an agentic approach. So it will be doing a few steps and iterations on the prompt improvement, and we'll see how the results is going to be. The other thing with LLMs is obviously that inference may take a bit of time. So if you do this in a way that the user, you don't provide any feedback to the user while you are actually doing some processing in the background, that it may be really a bad user experience. So I think with any LLM powered app, it's very important to think through the UX for how do you let the user know that actually there is progress being made that they cannot see yet. This is just okay. It's ready. Actually, we can rerun it real quick, and then I can hand it over to Nour to continue. We'll just take a quick look at the result with the structured output. It's basically now we can see that the model actually goes through a chain of thought. It analyzes the claims, each of them, determines whether they are kind of a red need to be flagged, are verifiable, etc. And then there you can see the output already in this nice XML format. And this is something that your pipeline should be able to use in later steps. So I think it's basically what I wanted to show just real quick is like you can actually go and use these existing tools to get to your first iteration of your prompt, and then you can go and improve it with existing tools, and you don't really have to start from scratch and wonder about what are all these different things that you could be doing. As long as you are aware of what is the end goal, what is the task, and you can specify it very well, then with the tools like the cloud platform, you can actually go and start developing and iterating your pipeline. And about what could go wrong, I think Nour is going to tell you more.
So, like Miklos said, it's important to have a structured output from your LLM because you'll have downstream applications and processes depending on it. But having structured outputs in the schema that you're expecting and with validated rules is hard. So you need always to enforce that the schema has been followed correctly. You can use tools like PyData or Instructure to make sure of that. You need to define rules to check for in validation. So for example, the claim ID should be an integer, or if there was no claims extracted, then you need a different field called reasoning to be filled. And then you can use tools like PyData to make sure that these rules have actually been followed. Another way to make sure that the schema at least is correct is to have grammar constraint decoding. This is something that has been around in the open source models for a long time, where you tap into the sampling layer and you make sure that you don't sample tokens that will violate the rules of your grammar. But now we have it also in closed models like OpenAI. And one thing that anyone that worked with LLM knows is that anything that can go wrong will go wrong. And now I'll go through a series of vignettes about what can go wrong when you have structured output. So the first thing that happens pretty frequently is that you have misformatted output. So you can see for the claim field here, the tag is opened and then it's closed, but it can happen that it's not closed, and then if you parse this, you will have a syntax error. You can also have special characters that aren't allowed in XML, but they exist in the original text, so you can see it under the text tag here. If you use this, you will have a syntax error, so you need to escape this to solve this problem. The same happens with the JSON output. So let's say we have the text enhance double quotes immunity. If you have double quotes inside double quotes in JSON, that will cause also parsing errors, so you need to escape it as well. And you have multiple ways to go about solving this. You can obviously retry, but retrying doesn't always work. So if you have double quotes, there's a low chance that retrying will get rid of double quotes. You have a bigger chance of having the LLM actually escape these codes if you change the prompt and tell the LLM not to have special characters inside the generated structured output. These two will get you a long way, but then a better way is also to combine this with creating your own regular expressions and then escaping in a post-processing step before you parse your structured output. Maybe another related problem is missing output. So you know that LLMs do not always follow instructions, especially when the input is lengthy or complex. So let's say we have this vital boost brochure again, and the LLM has not extracted the natural ingredients claim. We agree it's a claim, but we don't know if the LLM has missed it because it happened to miss it, or because it thinks it's following its instructions and that your instructions appear to say that this is not a claim. This is how we have the output currently, so you only have positive examples in the output. You have a text if the LLM considers it's a claim, and then you have a reasoning for why this claim was extracted, but you don't have negative claims. So if something is missing, you don't know why it's missing. A way to solve this is to add a Boolean field, is claim. So you can be sure that if something is missing, you have to retry to be able to get it. And then with reasoning here, you're able to debug why it wasn't considered a claim. So for example, here the LLM says that this claim refers to product composition rather than direct health or performance benefit. And then you as a developer can go and revisit the prompt so that you make sure you get this claim in your output. The opposite problem of a missing output is a hallucinated output. This happens, but we found empirically that forcing the LLM to provide a reason for each claim it extracts will lower the chance that you get hallucinated output. And whenever you have one, you are able to debug the problem in like a high percentage of cases using the reasoning. Now, how do we know that an output is hallucinated? We take the text, we go back to the original document, and we try to find the exact text. But sometimes we don't find the exact text, not because the claim was hallucinated, but because the LLM chose, despite our best efforts in the claim to tell it not to change anything and to be verbatim, it changed the claim's text. So you can see here just an example, an artificial one, where at the left side it says statistical significance with p less than 0.05 in 3 double-blind trials, and then you have the same information, but slightly reordered, slightly grammatically different. So it's the same information, but reformulated. And the way we practically solve this is by using the Levenshtein distance to be able to find reformulated text. It doesn't always work, though, because sometimes, especially in long, complicated, domain-specific documents, you have the first part of the claim on the first part of the paragraph, and then you have to scroll down to the end of the paragraph to find the last part. So the LLM is obliged in a way to string together two parts of the text to be able to create the claim. I've touched on retry a bit, and it's a solution for many of these problems, actually, but one needs to use it in a responsible way. You can't retry indefinitely, and you have to think about what you're retrying before just applying the retry as a universal remedy. If you are failing on a task because you've reached your API limit, then you need for your quota to be reinstated before retrying. It doesn't it's not a good strategy to just retry. If your temperature is 0, it doesn't mean anything to retry. It won't lead you anywhere. And you have to think about fallbacks. So you have to think about switching to another model or provider if your system is in production. And you can't tolerate just that it stops. You need graceful degradation. And finally, something that we found very important is to log failures and have metrics and an overall visibility over what types of failures we have, because it not only tells you that your remediation policies are working, it also tells you if the users start using the system in a different way or if they introduce a different type of documents that you haven't covered before. The rise or the difference in failures will be able to tell you that you need to change the prompt, change the system, depending on the problem that you have. You don't have to DIY that. We started by DIYing it, but it's a common enough problem for you to be able to do it with existing tools. So you can use instructor, for example. Let's say we have this double quotes inside double quotes problem in JSON. Instead of just retrying blindly and expecting the LLM to solve a problem that it doesn't know about, you can inject the error back in the input so that the LLM receives previous failure information. You can also use Tenacity, which is not a GenAI specific tool, but it helps you not DIY retries. It has automatic retries. It supports rate limit handling in APIs. It has exponential back off. It helps you conditionally retry based on the type of error that you have. I'd like to talk about evaluation just a little bit. I won't have time to delve into this deep, unfortunately, but let's just look at this for a second. So we have on the right side, so this is the same brochure, but on the right-hand side you have the human annotation, and then on the left side you have the LLM annotation. You can see that we have 3 claims here, and then we have a claim here that doesn't exist or isn't annotated here. Who can guess what's the accuracy, the recall, the precision of the LLM output here? Anyone? It's an easy number. No? It's 0. You see, the LLM wasn't able to get any claim. If you just rely on the text and you have your benchmark and you go through the confusion matrix, you can see that the LLM didn't detect correctly anything. But then you show this to the subject matter experts and they say, actually, this is an acceptable way of extracting claims. This is what I've done here is a personal preference, but it's totally acceptable for me for this to be extracted this way. And then this, I didn't extract it because of X and Y, but I don't mind it being extracted, and suddenly you go from 0 to 100%, which is problematic for automated benchmarking, to say the least. We still use benchmarking in our projects. It's very helpful to test regression, whether you're introducing new features, changes to the system, or you're upgrading your system to a new LLM model. But the gold standard will always be manual validation, which is time-consuming, and at the same time, it surfaces more about the domain than you initially thought. I have more to say, but we're out of time, so I'll skip these slides. I just want to point you towards our technical blog if you want to read more, and if you want to know more about our client use cases, which can be interesting, you can also go to the Modus Create website Thank you so much for attending this talk.
Thanks a lot. Any questions? Sure, just kind of.
We have a microphone.
Oof, flash. So no questions? Ah, sorry.
Hello, thanks for the presentation. So I have a question about retrial mechanisms and how they implement them. So for example, sometimes you get not what you want from the LLM, and if you change the prompt, you can get what you want, but you don't know before trying for every cases, and you might create like a fallback mechanism. We can create fallback mechanism, but then we need to implement for each cases and each different implementations. So how do you solve this fallback mechanism, retrial mechanism together?
Yeah, I'm not sure I followed completely. So you're saying that sometimes you have multiple use cases, right?
So for example, in our example in here, we have like this one prompt, and it gives us the solution, right?
Yes.
And sometimes it doesn't return anything from what we ask. But if we change the prompt a little bit, if we tweak around a little bit, it might give a right answer. Then, whenever it gives no response at all, we can actually try different prompts to get whatever answer we want to have it. But then we need to implement this logic one by one for each cases.
Do you perhaps get?
Yeah, it's. I think there is no like single solution for such things. So what you're saying is basically you have a pipeline where you have a step where if you don't yield any results, then you try another step, right?
Yes.
So then, yeah, you would need to do like multiple layers of retries. So first you have and this is why it's good if you have things like tenacity or instructor, because then you can say that if the parsing failed, for example, then the LLM generated wrong like response, then you can retry with, feeding back some information. But if you have parsed the response perfectly and it just doesn't have anything, then yeah, it's then you may go to another step in your pipeline and then do the same thing again. So I think it's just you need to think about these as building blocks. So one building block is really like one LLM call with the structured output and the retries if the parsing fails, and then you can queue these after each other if you want to, depending and make some if then else like just some branching logic. So I think that's the way that you can solve what you said. And the other thing is I would point out is that if you want to do this, like this increases a lot, like this adds a lot of complexity. So you would need to add the evaluations. So you would have to have like cases where you would want to fall back to the second step, which is another prompt. And you would also need to have evaluations for like whether you can do the retries and so some tests, not necessarily these evaluations, but I think it's all around like if you increase complexity like this, make sure that you actually have the testing in place / evals in place. Otherwise, you will never know if you change any of those prompts. If you have like 3 prompts that you could do after each other, and then you will never know if it improves the system or not. So our experience has been that basically the crux of all of these systems is like you need to have like the ground truths defined, and you need to know like what's good output and what's not good, because then you cannot go on and actually change the system in any way, because then you don't know what you end up with. So I think what you said is it may solve some problems, but it also increases the complexity, and you have to put in place the things that will kind of mitigate the complexity increase.
Thank you.
We have time for one last questions. If no one has questions, oh, there's one. Otherwise, I had questions. Okay. So unfortunately, there will be only one. So you can go and ask the speakers afterwards.
Thank you. Very interesting talk. From my understanding, what you presented is an example where you have like a one-shot task that you use your LLM to perform, And I was wondering if you know, if you have a more conversational task where you expect people to provide feedback, if there is a way to benchmark that type of thing.
And that's like Digent. I'll let you talk about that.
Yeah, it's a hard one. So yeah, we also have an internal project where we worked on such evals. So what we found working is basically, it's called task-based evals. So what you do is basically you check if you have this kind of conversation, you replay a conversation from an actual conversation, or you have just some synthetic thing like let's say like you just drop in some question to the agent, and then you figure out like what the agent does, how does it answer that. So task-based evals are good for checking if you have arrived at a certain outcome that you would expect as a user. And so for conversational things, this is what we found actually working really well, because then you don't care about if you arrived at the last, like at the outcome in 5 steps or 3 steps or 10 tool calls versus 7 tool calls. You just care about whether the agent has answered the question, like who attended the meeting last week about, I don't know, our next quarter's compensations or something. Then this is a quite kind of specific question, but you don't really care how the agent arrives at the answer, and it could be doing it in multiple ways. So it could be finding the meeting notes on Confluence in your emails or whatever. And you really care about the outcome. So I think task-based evals are helping with that. So then, they give you the way to basically not have to hard code what is the path to come to a conclusion or to an outcome, but really just verify, have we arrived there or not?
Thank you.
Thank you. We can thank the speakers again. And in 2 minutes, we have another talk.